Hello everyone, it's September. I was thinking about Thanksgiving already. September the 9th. All right, let's go right into it. What do we have? Largest plus sign. What does that mean? Oh, oh wow, this is interesting question. You're given an integer n and an n by n binary grid with all values initially ones, except for some indices given in the array mines. The ith element of the array mines is defined as blah 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 as a coordinate where that grid is a 0. Okay? Return the order of the largest axis aligned plus sign of ones containing grid. If there's none, return 0. Man, I gotta say, how did they come up with all this stuff? This is a very interesting question. You have to see it. I have to see like how the picture looks like to understand it. But like, how do they come up with all this? Who is behind LeetCode's team, making all this stuff? So you're given this, right, and you find out the largest plus sign. That's interesting, huh? An axis-aligned plus sign of ones of order k has some center equals 1, along with 4 arms of length k minus 1, going up, down, left, and right, and made of ones. Note that there could be zeros or ones beyond the arms of the plus sign. Only the relevant area, I'm doing it again, only the relevant area of the plus sign is checked for ones, okay? So output is 2 because we are extending 2 minus 1 is 1. We're extending 1, right? The largest plus sign can only be of order 2. One of them is true. Yeah, we can do any of this, but if we want to do more, we hit a 0. And this is a 0. All right, we have 500, and all the pairs inside is unique. And we have one hint. All right, so think about it. So it's n by n, right? The largest will be the thing in the middle. Well, it depends on if it's even or odd number. If it's even number, it's going to be one of the 4, right? So it's fine. So let's just say it's an odd number, so it's in the middle, right? So what we need to do is to check if this one is, and then we have to check all these, right? And if it's not, and that means we cannot get it. So the next option is this, right? And then we go a little bit smaller. Okay, but what we're going to do, we're going to have to check only one of them, as long as one of them works, right? So check this. Let's say it's no good. Yeah, it's the surrounding. Yeah, surrounding. We pick the center, and we have to find surroundings. And if that doesn't work, that it's wait. How about it just by itself? Can we order of 0? Wait, hold on. What if equals 1? Mine's length, we have to have a mine regardless. But like, let's say 2, right? If it's 2, doesn't matter. It's gonna be 0, because if n is 2, it's gonna I didn't return anything. If it's 2 by 2, there's nothing, right? 2 by 2. Wait, hold on. 2 by 2, we can form one? Expected answer is 1. Oh, so by itself, right? If we go 2 by 2, then by itself we can say, well, the rank is 1, so it doesn't extend. Ah, I see. I see where this is going. Okay, so 3 by 3, we're going to check this. And check the remainder. 4 by 4. Yeah, I'm just drawing it out, trying to find inspirations. 4 by 4 will be in the center, right? Will be something in the center. We can say 4 divided by 2, which is 2. So we go 0, 1, 2. All right. And then 5 by 5, we're going to do the center, right? And then something outside. And a systematic way to check. Hold on. What we want is this shape, right? What we want is this shape. What are we thinking? Well, we are thinking rank of 1. If there exists 1, then we have rank of 1, right? And to get rank of 2, we have to check this. We have to check these, right? Everything inside this for rank of 2. That will require. And I can just like say go here, check. Go here, check. Go here, check. Go here. No, it's a go here. These, this, and this. We check for rank of 2. And for rank of 3. I mean, I think it should go the other way around, right? Check the highest rank. And check the highest rank. And it's 500. 500. We can check the highest rank, which you can find, right? So if n is even, just going to be n divided by 2 and n divided by 2 minus 1. That's, we talk about the coordinates. If this check so we can just go around, right? We go around, so we check this if it's good, and then we go up to see if that is that means if I need to see this, then these 3, like if I'm saying I'm going to check the plus sign centered here, I want this and this to be all 1s. Can we make this easier to check? We can go 1 by 1, but I feel like if we go 1 by 1, what we want to know is if this range contains any of the values here, right? That's what we want to know. So the mind will give you a bunch of points. And the question is whether a range contains one of the values down there, right? Can we run a fast way to check that? Just given a range, I want to know, given a range, right? I want to know whether a value is in it. Yes, we can do that, right? That's what we want. Just given a range, so we can sort this. Not sort this. We turn mines into two, because everything is unique, right? So the pairs are unique. No. We should turn that into a dictionary, right? So dictionary, one is with key on the row value, and the other key is going to be column value. So we identify a center, and then we are asking a certain range. We have a certain range, and we want to say whether at that row, right? At that row, does one of the things appear inside this thing? How do we check? Well, if we sort this, we have to go one by one, right? We have to check one by one to see if they are inside this range. Now we have a range, right? We have a range, and then we can, it's 5,000. So at most we have 500, right? At most is 500. We can binary search it, but I feel like binary search might have some overhead. We probably just iterate through to see if anyone's inside. Yeah, we go iterate through it, see if everyone's inside. If no one's inside, we're good. And then we go on a column and see if anyone's inside this range. If no one's inside, then we find it, right? So all we need to do now is figure out a way to systemically check the center. So we'll have the center, right? If it's odd number, we have a center, and then that's the first round. And the second round will be the center just go up, right? Well, it's not just go up, it's like something surrounding the center, right? Surrounding the center, and including the center as well. Hold on. So for each one, right? For each one from the center. So the center we can check for all the possible ranks, right? So we have the largest rank is no good, so we cut it short, right? So for the center we can check all the ranks, and once we're done, then we go out, we check around. Once we're done, we go one out, we check around. So once we're done, we go diagonal, right? Diagonal here, go around, diagonal here, go around. So for each one, we're just going to check every single possibilities. That won't be too much. Will it be too much? So we will check every single possibility. So we're talking about 500, right? So 500 on the center. How many possibilities do we have? Well, we have divided by 2. Okay, so 500 by 500, right? So it's 250. It's actually, so 250 minus 1 is 249, right? It's 249. So 249, if it's not working, do we go again? You know what, that would be a better way. So we check this, right? Check this. So for this case, we check it. We know the largest that can go will be 5 divided by 2 is 2. That's the largest we can get. And then if it's even number, it's going to be n divided by 2 minus 1. Oh, this can be divided by 2 minus 1. Oh, no, that's not minus 1. N plus 1 divided by 2. So n plus 1 divided by 2 minus 1 is the maximum rank we can get for both even or odd. So for this one will be 2 if it's even number divided by 2 minus 1. That's the maximum we can get, right? So from there we go. So that's the first level, and then we say, well, we start with this. And if it doesn't work, go back. Now we minus 1, right? When we minus 1, we are going to go up. So everything we can just search, right? If it doesn't work, go up, everything until the smallest. The smallest will be 1, right? The smallest will be 1 just by itself. And all we need is one of them to work. One of them to work. What's the runtime? Do this. And then I have to do this. And then in here I have to do this. Every single one I have to check. Ooh. If one of them works along the way, if nobody, like if it's no good, no plus sign, then we have to go through every single one. I'm talking about O(n) tripled. Alright, it's not just O(n) squared, because it's going to be 1 squared plus 3 squared plus 5 squared, right? Plus all the way down. That's going to be the runtime. Okay, so that's like just to search for it, right? Can we do better? Let's say, like, can we analyze based on the mines? Well, we might be able to analyze based on the mine. So let's say the mine is 4, 2, right? So we know on this line, nothing can live on this. And again, like we're trying to go for let's say first we can check the number of mines, right? If the number of mines is the same number of cells, then it's going to be a 0. So there'll be no rank 1. Otherwise, it will have rank 1. And now we need to see if it's possible to get rank 2 based on the mines layout. Now, for rank 2, we need to have some 1s in the center. Wait, how do we rank 2? Yeah, let's say just we have the zeros somewhere, like zeros here and zeros. Let's say just like 1 0, right? If I have 1 0 and then we have 25 ones, then they gotta be a rank 2, right? Because rank 2, hold. So like if we have this, right, a 0 at column 2, then we can guarantee at the row 4 column 2, right? So we can guarantee, because it's column 2, so we can guarantee that it will not have the maximum, right? It cannot have the maximum because we're at a strategic place. And column 4, on row 4, yeah, so we look at the column, right? So the column, whichever column will guarantee that, like we know there will be no rank 2 and there will be no rank 1 for this because of this column. And in the row, we can guarantee that there's no rank 1, and no rank 1 at this one. That's all. That's it. Because rank 1, the row cannot go here. Okay, so we can analyze, right? So analyze. Okay, so for each mine, we analyze. There is no rank 2, okay, and no rank 1 at this position, and no rank 0, right? No rank 1. Again, no rank 2 at this position, no rank 3 at this position, right? And then no rank 1 at this position. That's column. Now row-wise, because we're at the bottom, so row-wise is nothing. So by doing this, right, we can compute how many impossibles, right? How many impossible for each rank? Because we can easily compute, if this is 1, we can easily compute the total number of possible plus signs, right? That's what we can do. So, like the total number of rank 3 will be 1. Total number of rank 2 will be just surrounding 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 rank 2, and we have 25 rank 1s, right? So we can compute rank 3 is going to be 1, rank 2 is going to be 3 by 3, right? 3 times 3, and rank 1 is going to be 5 times 5. So we can do this to make that into a dictionary, right? And then we go through each mine. And find out at this 0 which one we cannot do, right? We find out which one we cannot do, and we put that into another dictionary, right? So another dictionary will be, let's say, also like rank 3, like any rank. Let's say we cannot do, it's gonna be a set, right? When we put the coordinates in the set. I'll say, okay, at this rank, and this one we cannot do. And as we go through everything, we will figure out all the plus signs that we cannot form because of this 0. So that will take us 5,000, ON 5,000. Now each one will have, depending on your position, right? I think depending on your position, like this position, we consider rows and columns, right? So if the rows is at the end, then rows doesn't matter. But for a column, how do we figure? I'm at column 2, row 4, right? So in this one, I can consider myself at the center. No, at the column, I consider myself from top to bottom. Like I say, okay, if I am at the bottom of a plus, then what I cannot do. So I say, if I'm at the bottom, and then I will negate this entire. Anyway, so if I have a 0, I will negate the entire row or entire column. And I will also negate what would be this? What is the? If I'm here, right, at 0, so I say this entire row, entire column cannot work, right? It cannot work. Then how many are affected? How many plus signs are affected? So affected a plus sign by myself, right? Like centered around myself. Like the plus sign is centered around something, centered around. So the plus sign has to involve this row and this column, right? And it has to be something in between. Has to be something in between. So anyone that's in between cannot go. Like this one cannot go. And this one has different ranks. Yeah. And then say this one cannot go. And this one has different ranks. Hold on. I'll be back. Oh, this is one more time. So when I find a 0, I need to figure out what are the I need to figure out what are the plus signs that can be formed if I had not been a 0, right? That's the question. But how do I know that? How do I know that? Because I am going to be occupying a row and a column, and the plus sign can only form for a row and a column. So all the plus signs will be forming on a row and a column involving me, right? So the center of the cross sign must be on the same row or on the same column. It cannot be anywhere else. Okay, that's a good observation. So on the row, where can the center of the cross sign be? So we can say from start to end, on a row, can this be a cross sign? And like what involve me? Well, cross sign can only form inside, right? So it can only form inside. So we check. Oh, but it cannot be because I'm in the way. So that's one. And then for this, for cross sign level 1, cannot do, can do. Level 2, oh, cannot do. Rank 2 cannot do. And this one has only the top of level 2. So okay, these cannot do. And this one, and that's it, right? And then for the column, the same thing. So basically, let's say if like I am here, right? This is me. So I know the center of the cross sign must be in either this row or this column. So I check. Well, this row cannot be because it has to be within this region, right? So I just check here. This one, rank 1, yes. Rank 2, no. So that's no. Rank 3, no, it cannot do rank 3, so pass. Here, rank 1, yes. Rank 2, yes. Rank 3, cannot do, so that's that. Here, rank 1, yes. Rank 2, yes. Rank 3, rank 3 cannot do. like we don't have to keep checking, right? How do we reason? Like we don't have to keep checking. We just need to check here, and we don't have to keep going. Well, it's like if the distance, right? Because we're talking about the distance. If the distance between these two is, let's say, longer, right? If the distance is longer than the maximum rank, then we just stop. And this distance is, maximum rank is 3, right? Which means the distance between these two is going to 0, 1, is 3. It's 3. So now we have to check this for 3. And, hold on. So we check here, the distance is 1. So we say, oh, rank 1 cannot do. I check here, the distance is 2. So we say, oh, actually this rank 2 cannot do. Check here, distance is 2, so rank 2 cannot do. Rank 3 cannot do. And that's it. We don't have to keep checking because this we 1, 2, 3, 4. We rank 4. We cannot do rank 4. Oh, okay. Okay, so what I'm saying is for each one, we just need to extend. Alright? We just need to extend. Then we say, oh, this cannot do. Extend, oh, this cannot do. Or extend here, extend, extend. Well, it's starting from myself, and I extend. Then all the one that cannot do, we put in the dictionary, and then at the end, we're gonna just go from the largest rank down and see if the count is larger than what cannot do. That means we have formed at least one in there. All right, let's try it. Oh, this one doesn't feel easy at all. So we need two things, right? First thing we need is the count of how many we can do. And then we need to figure out, based on the mines, what cannot be formed. Right, so first of all, we're going to say max rank, max R, is going to be n plus 1, right, divided by 2 minus 1. This is the maximum rank we can get. Secondly, what we're going to do is figure out a dictionary. I would say total count. Right? Total count. Total count. Do we keep that? Or maybe we can compute it on the fly. Yes, we can compute it on the fly because, oh wait, probably cannot compute it on the fly. Now, can we compute on the fly the total count? Yeah, sure we can, right? So like count 3, right, will be 5 minus 2 minus 2, right? 5 minus 2 minus 2. So it will be the n, let's say it's being n minus 2 times, minus 2 times what? Minus 2 times, no, it's the largest rank is either 1 or 4, based on whether it's even or odd. That's it. So the next one will just be, because 1 is going to be 1 by 1, right? 2 is going to be 2 by 2. So next one, the size is 1 plus 2 or 2 plus 2. So next one is 3 squared or 4 squared. right? And then next one will be 5 squared or 6 squared. So we can compute that, right? We can compute that. So we don't need to do another dictionary. So all we need to do is impossible, right? Impos, called impos. It's going to be a dictionary. Let's call it no. Yes, from collections, import default dict, right? So impos is going to be default dict set. We're going to put a set in there, right? So what we're going to do is for xy in minds, right? So we're going to find out what are the impossibles that we cannot do. So here's how we do, right? So we need to find for the rows, right? We need to check rows, right? Check rows. How do we check rows? We go from myself, and we first of all, so check rows. We're talking about x. So if x, so x has to be 1, x actually 0 smaller x smaller n minus 1, right? Because no, yes. So because it cannot be the first row. The first row will be nothing. Last row will be nothing. So it has to be in the middle, right? Once I'm in the middle, then I'm going to say I'm going to start counting towards the outside, right? Counting towards the outside. So what I'm going to do, I'm going to do for rank. So for R in the range from rank of 1 to max R plus 1. So we have these range, right? We have these range. And what we're going to say is the column, right? The column. So I think will be, let's just call rank, right? So now the column is going to be starting from Y, right? That's the current column. And we have the rank. And we say if and we also have to know, actually no, we have a new rank because it's going to be based on where I am, right? So if it's this, then we say mostly likely the possible rank, right? The possible rank is based on where I am. So the possible rank is going to be the distance between me to the top and then me to the bottom. Take the smaller one, all right? That's the maximum rank that I can afford. Oh, and the left and right as well. Oh, so the max possible rank. Max possible rank is going to be, so given my position, we can actually do it here, right? The maximum possible rank will be the minimum value of what? Of x, right? So 2, 3. The rank will be 4, right? So it'll be x or n minus 1 minus x, right? And y and n minus 1 minus y. So that's the most possible rank. Will be this plus 1. So if I'm here, that'll be 0 plus 1. 4 minus 3 is 1. 1 plus 1 max rank is 2. So the max possible rank is going to be this. And here is going to be max possible rank, right? So if x is in this range, right, and then we say for rank in this 1 to max possible rank, and we say if no, we're gonna move x on the rows first. So we're gonna say if rank minus 1 plus y, right? So rank minus 1 plus y is in 0 smaller equal to this, smaller equal to n minus 1. That means this rank, right? This rank cannot be formed, which means impossible rank dot add, right? We're gonna add what? Row x plus column is going to be rank minus 1 plus y, this thing, times 1j, right? So that's this is the center, right? This is the center, and rank as 1 is going to be itself, right? This is the center, so we're going to add this. If this, and then similar thing, because we're going to go left and right, so it's going to be, let's say y plus. I like to do y plus. So y plus this, and then y minus this, right? So y plus this and a y minus this. Y plus the rank and y minus the rank. Right? 2 ways, left and right, and until it exhausts, right? Until it exhausts. Now once it's done, similarly, we're going to do on the y side, right? So I'm going to say for y, if y is in between, and then for the rank, the same thing, rank has to be this, and then we say if x, right? X plus this, and then we're going to add this thing. It's actually x plus rank minus 1, which we don't have to do parentheses, and this is going to be y times 1j, so y times 1j, and this is again it's x. Ooh, it should be minus rank plus 1. Yeah, minus rank plus 1, because there's a parentheses. There's a parentheses, so plus 1. So the minus rank plus 1, and we're going to do x minus rank plus 1 plus y times 1j, right? So that's for each MIMEs. I can get all this, and once we're done, we will have the impossibles, right? So then the next job is we're going to say for rank in range from top down. So maximum, this is the max rank we can get, right? And then 0 minus 1, right? So that's the rank. A total is going to be, I'm gonna compute, come on, compute. What we also need is, can we get based on the rank itself? Let's not do that. Let's just say size, right? Size gonna start be n divided by n this, right? Size is going to be 1 if this, else size is going to be 2, right? So total going to be size times size, and num impossible will equal to len impos rank, right? And what we say is if size squared is larger than number of impossible, then we return rank. Right? Otherwise, size will be plus or equal to 2. Right? And then this one will keep going, keep going, keep going. If no return, when no return, then 0. Okay. All right, let's try this. So first one is 5, and we have 4, 2. Answer should be 2. Second is 1. We have 0, 0. Should be 0. And we have a 2. 0, 0. Shall be 1. Alright, and then this is going to be n minus, and this is ordered cosine n minus. Okay. Alright, let's see. We pass, but we fail the last one. Alright, let's see. How do we fail the last one? We pass these, but we fail the last one. Alright, let's print out. Let's print out the impos, right? Impos is n is 2. 2 plus 1 is 3. 3 divided by 2 is 1. That's not right. What is the maximum rank? It should be n divided by 2. Right? Isn't that n divided by 2? So if I have 2, right, the maximum rank is, so n divided by 2 is 1. Oh, I think we're talking about different things. So I think it's just n divided by 2. That's rank. That's rank. It's n plus 1 divided by 2. So if it's even number, it's just divided by 2, right? If it's odd number, then we're going to be 1 more. There we go. Actually, that's not right. It can stay on the side. You know what? This is actually not right. We have to run through both, because on the side, we, there you go. We're limiting 0j. Okay, so let's run the others. Alright, we have issues on the first one. This one we have issue. What happened? Alright, res 3. Oh, we did not find. Ah, that's not right. It's true. You know what? Maybe we shouldn't do this. and we just go max R. How about that? We just go max rank. We check all. Check all. Max rank. Yeah, we check all. Check all, and this is actually max rank is actually not this. Max rank is this. Here is going to be max rank. Yeah, if you look at this. 1 is this. 2. Rank 2 is going to be 3 2. Uh, 4 3 and 4 1. 4 3. How could it be 4 3? No. This is not right. Right, so what we're gonna do, what we're trying to find all right, hold on. The possible, so we have the X, right? And I'll have the possible Y, right? So the possible column, and then it has to be, what am I missing? I'm talking about on the row, right? On the row, if we say this has to apply to the row, then the max rank is the minimum that it can get, right? If it's on a row. So check rows. You know what? I think this is still right. So we can put it here, right? So check rows. This is not this. But it's, if we check rows, it's only X. Right? So we're not going to talk about Y. It's just X. I'm going to main of this plus 1, that's the rank, and a plus 1, we're going to get the rank. And then we're going to check the Y. And then here is the same thing, but here we're just going to check on the Y, right? Check on the Y and do this. Now we're talking. So we have 4 2 rank 1, and rank 2 is only this, 3 2, and rank 3 is this. Right? Rank 3 is this. No other rank is affected. Okay. All right, let's try it. Check rows, check columns. Oh, closing on to 1 hour. Yeah, just submit it. Let's see. Pending. Judging. Oh, it's so slow. Either wrong or we timed out. Oh, we are wrong. Let's take a look. Input 5. Okay, let's try it. Output 1, expected 2. Right, so we have a 5 by 5. So 1, 2, 3, 4. 1, 2, 3, 4. 5 by 5. So 0, 2. 0, 0, 1, 2. So that's a 0. 0, 4. 1, 2, 2, 2, 0, 2, 3, 2, 4, 3, 4, 4, 2, and 4, 4. Okay, so, yep, I see it. All right, let's run this. Let's see what we have. So it's going to be this, and answer is 2. But we got 1. It's fine. All we need to do is check the print out the impossible. No, kind of no. Print impos. All right. So basically, what we cannot form, right? What we cannot form. So for 1, what we cannot form is. Now we should need to know the rank 2. Let's go just rank 2. Rank 2. So this is the rank 2. Oh, rank 3 is also not correct. There should be only one rank 3. Why would it have so many rank 3? Should be 0, 1, 2. Should be 2 plus 2j. Why would we have 3 plus 2j? And 2 plus 1j. And all right, something is wrong. Something is wrong. All right, again, so we're talking about a row, right? We're talking about a row. We will say the max rank we can get on this row is the smallest of this and minus 1. Okay, I think this is correct. So now we get a rank, right? And then I'm going to say maximum rank. Well, within the rank, and then if what we're trying to find, this is the center. So no. All right, that's potential y equals y plus rank minus 1. Right, that's potentially where the center is going to be. But then what we need to do is we already computed the rank. So on like for row wise on the height we get. So what we want to know is on a column wise, right? On a column wise. So if this is the center, right? If potential y is the center, which means we move 1 out, and then if it's y plus the rank minus 1, so we move to the right. So what we need to say is if potential y, right, potential y plus rank minus 1 is smaller or equal to n minus 1. If that's the case, then we add, all right? Or if potential y minus rank plus 1, let's go to the left, right? So move to the left. This one has to be larger or equal to 0. Yeah, so we cannot check on the y itself. We have to check on, and then these just gonna be so it's gonna be this times 2. right? Y plus this is this value, right? Potential. And this, so times 2. Then we add this. And this can be minus, so it can be y minus this times 2. Then we add that. So it's the same thing. So x plus this times 2, right? And this is x minus this times 2. Larger equal to 0. And we add this. Now we run. Now we pass. Because the 3 is only 1. And let's try the others. Alright. Again. Yeah, I feel like we are on the right path. Submit. Pending. Judging. Ooh. Wrong answer again. Another one. Alright. It's already at the current state. We're just going to do testing. Expected 1, output 2. Oh, it's the opposite as what we had earlier. Doesn't matter. Oh, I think this one is the right way to go. So we're gonna keep doing it. Okay. All right. Again. Let's draw it out. 1, 2, 3, 4. 1, 2, 3, 4. All right. So we have 0, 0, 0, 3, 1, 1, 1, 4, 2, 3, 3, 0, and 4, 2. What do you know? It shouldn't be 2. It should be 1. Alright, so this is what we have. The 2's we cannot form shall be everybody. How many do we have? 1, 2, 3, 4, 5, 6, 7. We're missing 2. Let's check 1. 0j. 3. 1 plus 1j. That's not correct. No, that's correct. My bad. That's correct. 3j. And then 4 plus 2j. 4 plus 2j. 2 plus 3j. And 1 plus 4j. That's correct. And the 3 is correct. So the only problem is 2. Alright, we have 2 plus 1, so 2, 1. So check 2, 1 is no good. 3, 1 is no good. I think I know. I know. We forgot to add itself. So impulse rank dot add x plus 1 plus y times 1. So we forgot to add this. And this. Yeah, because it's like the 0 is the center. That's because we're missing 2, and that's the 2 that we don't have. There we go. See? That's the 2. And if we get the rest. Ugh. How? I add myself. Fine, let's go back. Let's go back. What is wrong? A lot is wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13. Jeez. And a 3. How? We need to check. All right, rank 1 we added, that's fine. How about rank 2? Like, the question is, can I be of rank 2? But I already checked. On the Y. On the Y. I see. So we have to check on the Y. My, there's gonna be a lot of checks. It's gonna be like if Y plus rank minus 1. Alright, so we say X, we're gonna do this rank. Now we're gonna check the Y. So if Y plus rank minus 1 is smaller, actually it's gonna be smaller than n minus 1, then we can add myself. No. No, because I am looking, so it has to go both ways, right? Then this is fine. For me, I have to check on the right side, and I have to check on the left side. Yeah, I have to check on both. So if this is smaller than 1, and Y minus rank plus 1, check on this side, on the left is larger than 0, then I can add myself. And the same thing is going to happen here. If X, right, going and X going, then I add myself. Okay, so again, let's try the others. Okay. All right, let's try one more time. Third time, 3 times the charm. All right, let's go. Pending, judging, still judging. Still missing something, huh? This is a 10. What are we missing? I already restrict the range, right? I restrict the range. I restrict the rank, right? So the rank, I'm checking the rows, so I'm using X. So I know what is the maximum rank I can possibly get, right? And then I check if I can be the center, which just me, plus the Y, right, plus rank minus 1, and minus rank plus 1 if we're within the range. Because I know the rank is fine. I already checked, basically checked the rank here. Then I add myself for the rank. And then I check if I am at the edge. Right? If I am at the edge. Why am I at the edge? Good question. Why am I at the edge? I don't have to be at the edge. It should be everything from this that can including me, right? Yeah. I need to rethink this. So the possible center, right? The possible center is myself. Or can go, to the left, to the right. So it can go, this is a possible center. And so this is a possible center. This is a possible center. So the possible center to the right, the possible center to the left. You know what? I think I know why this one failed. One more time. Should be 2. All right. One more time. So we think about the center. I know the rank, right? I know the maximum rank that we can get on a roll, right? So what I need to do is from the center, we move to the right, and then from the center, move to the left, right? And then as we go to the right and to the left, we see the maximum rank that it can achieve, right? So the maximum rank it can achieve. The maximum rank it can achieve that will involve me. So like everyone along the way will be included. Everyone along the way will be included. So with the maximum, right? So like if I'm here, that would get the max that involve me. If I am moving one slot, then the maximum will involve me as well. Hold on. We'll check rows, right? We get the max range, max rank. Max rank be determined by the column, by the row, right? And once we do that, we need to find along the way, right? Along the row, we have different columns, and then we want to know at this column how many ranks can we get, right? At each position, how many ranks can we get? Yeah, that's the question. How many ranks can we get? So at this, we can get, let's say, the distance between this and that. That's the rank. And then, so at each position, I have so the max rank I can get. So at each position, I have a distance towards my point, right? I have a distance. And I also have the max I can get based on the distance between me to the border, right? If this is smaller than this, then it's no bueno. we keep moving until we move to a point where the distance between me and the 0 is equal to or smaller than what the distance from me and the border, right? Once that is reached, then we can add 1 from this up until I reach the end. So limit, rank limit, rank a limit. Are you saying we just check the entire row? Okay, rank lim equals min x n minus 1 minus x plus 1, right? That's the rank limit. And then what we can do is go for y, for potential y in range, right? That range is going to be based on current y, and we do rank limit to the left and to the right, right? So current y, say minus rank limit plus 1, because we go to the left, the most left we can go, because if we go even one more to the left, then the rank limit is larger. So we go the maximum rank limit we can go, and then y plus rank limit minus 1. That's to the right, plus 1. But we have to go, this is going to be max, this, and 0. Right, this to the left, because and then this will be minimum, this, and n minus 1. Right? So that's the range of potential y can be. Now, once we get the range and the potential y comes out, right? What do we do? Potential y comes out, and this y can get whatever the rank, whatever the distance between potential y and the y, right? The distance between the two, plus 1 will be the rank. So it will be the rank limit towards this. So it's going to be 4 from the rank limit, because definitely we're talking about larger than rank limit. No, smaller than rank limit, right? Smaller than rank limit. So it's just going to be the distance. So it's going to be for rank in range, the smallest rank that I can achieve, right, is this. And then the largest rank I can achieve is this. So the smallest rank I can achieve is going to be ABS y, potential y, minus y plus 1. That is the smallest rank I can achieve. Smaller than that, I won't involve the 0. So that's that, all the way to rank limit. So from the smallest rank to the biggest rank, these are that I can form that will involve the mine. So for these ranks, when I say impossible rank, right, dot add x plus potential y, no, yes, times 1j, right? So for all these ranks, so like if I am very close to the 0, right? So it could be rank from 1 all the way to whatever, and all of these is impossible. So when I do that, that is to check rows. And then we do the same thing for check columns, right? So the rank limit is going to be it's going to be y, and it's going to be potential x in range x minus rank limit, and x plus rank limit, And then for rank in range, this is potential x minus x plus 1. And then we say it's going to be potential x plus y times. So we remove this. Try it. Ew. Still not right. Actually, let's try the others. All right, we have another one wrong, so we can at least take a look. 0, 1, 2. All right. Pause. All right. Oh no, that's not right. How? It's like including everybody. Rank limit. So that's actually this one. 0 to oh no, it's not. It's this one. What he's saying is rank limit. If I get a rank limit, right? Yes, I have the rank limit, which is the minimum of these, and then potential y is going to be the maximum of these two how could it be 2 plus 0j, right? Like, what if it's a 0? Let's use this example, huh? So let's say I'm here, 4, 2, and the rank limit is going to be 4. This is 0. So rank limit is 1. Rank limit is 1. So in range, so I'm going to go y, right? Y. Y the range is going to be, there's 1, minus 1 plus y. That's going to be 0. 0. No, that's not 0. Y is not 0. Y is 2. Y is 2. So that's 0. So max will be 2, right? 2. And then this is 0. And then min 2. So it's going to be 2. 2, right? Y is 2. And I say for rank, dang it. That's fine, right? Y is 2. Potential y is 2. Y is also 2. So 2 minus 2 is 0. So rank is from 1 to rank limit. Rank limit is 1. So 1 to 2. Right? So rank is only 1. So I can only do 1. So that's actually fine. But what hell happened here? 2, 0, 2, 1, 2. So row 2, right? And then y just go nuts. Y we go 0, 1, and 0 and 1. Right? We go 0 and 1. How? Rank limit is if rank is equal to 3, we're going to print xy and potential y. And here, same thing, and a potential x. Rank is 3. xy is 0, 2. Okay, 0, 2. And then potential y is 0. What the hell? A bit more of a rank limit. Print the rank limit as well. Rank limit is 3. 0, 2. How is rank limit 3? Oh, actually I don't know which one is which. Huh. So we have to also print row. Right, and then this one will be column. Check row, check column. Yeah, this is column. Let's go row. That's fine, it's a column. So 0, 2, check column, okay? And rank limit is going to be y. Y is 0. No, y is 2, right? So n minus 1 is 4, 4 minus 2 is 2, and the mean is 2, so the rank is 3. That is correct. Check the column, so we move on the x-axis, right? So the max rank is 3. So 0, 2, and you're telling me the potential x is 0. Yeah, that's not right. That's not right. Well, what are we doing here? Trying to see where can we put. So we say in range, potential x minus, so x is 2. Potential x, and we say the rank limit is 3, so we can have rank limit is 3, right? So potential x in range x minus, so x is 2, 2 minus 3 plus 1 is 0. So you see potential x can be at the top, right? And potential x can be at the bottom. These are where the x can potentially be, right? Potential x. Because I can be as out as I want. So right, so this minus this, but I have to be contained within this. And then for this x, yeah, for this potential x equals 0, it has a limit of what rank can get, right? And the limit is potential x minus x plus 1. That is the limit. That's the limit. Right? That's the limit. That's the limit. Hold on. That's where it can go, right? That's where it can go. It should be from here. So it cannot be even smaller. But the large one is not rank limit plus 1. That's the problem. Rank limit is the maximum possible that we can get from this position. But now we're also moving on the other direction. So this has to be based on x, right? Based on x, which is min potential x n minus 1 minus potential x plus 1 plus 1 plus 1. Right? Now potential x is 0. Then this will be 0. It'll be 2. So it'll be 1 to 2. So I can only do 1. Yeah, because I limit some checking columns, right? So I first limit based on column on how big the rank can be. And then as I go through different x's, each x has its own limit. Here is doing the own limit, which we have to do this exact same thing up in here, right? This is going to be potential y, and this is going to be potential y. Now once we do that, and let's comment on this, let's see if this one gives us a right answer. No, still not right. So now let's take a look. We're still having a problem. Okay, it's fine, that's fine. Let's get to it again. But I think it's much less. Okay, row. We're gonna row. 0, 1, 2. So 0, 2. 0, 2. So row 0, 2, potential y 0, 1, 2. Okay. And then rank limit. Rank limit is 1. What happened here? It should be the rank limit and this, the minimum of the 2. Holy moly. Because this one, potential y is 2. And then it becomes 3. So it's the rank limit. So it's the minimum of rank limit and the rank limit and the new limit. Right? It's both. The rank limit and the new limit. So this is going to be minimum. The rank limit and the new limit based on where we put. So it's constrained by both. Now we pass. Now everything is 2, 3, 2, 3, 2, 3. Now 3, rank 3. And then, okay, so let's not print this. Not print this. Alright, let's try it. Oh, we pass everything. Do we dare? We dare, baby. We're already here. 1 hour and 34 minutes. Let's do this. Alright. New logic. Alright, let's see. Pending. Judging. I think it's still not right. My God. My goodness. Oh, it's correct. But we TLE'd. Alright. That's it. I'm gonna call it quits. TLE. Anyhow, the logic is to find what what plus signs cannot be formed by checking each mine. Once that is done, we can compare what plus signs at each rank cannot be formed by checking them. Once that is done, we have the total number of impossible plus signs at each rank. Then we can compare the impossible count to the total count at each rank. If the latter is larger than the former, we are sure a plus sign of that rank can be formed. It's too slow because there are a lot of checks, right, at each mine. So yeah, it's not working, but it's TLE, so that's fine. I'm a bit curious, how many have we passed? But we have a hint, so let's not go to the, let's see. For each direction, such as left, find left RC, the number of ones you will see before a 0, starting at R and C, and then walking left. You can find this in orange. Right? The largest plus sign at RC is just the minimum of left and up. For each direction, find the number of ones you will see before a 0. Find the number of ones you will see before a 0, starting at this position, and then walking left. The largest plus sign at RC is the minimum of left and up. The largest number of ones you will see before 0. So at this point, number of ones before I see, number of ones before I see, and the largest plus sign that can be formed at this position hold on. What are you trying to say? At each position, we go this and this. We go this and this. And of course, we first know the minimum possible by checking. And then we go this and this. So we say the largest ones, large number of ones you can see before hitting a 0. Right? The largest number of ones, the number of ones you see before 0. So at each point I have a value. So this one will be 1. This one will be 2. Right? This one will be 2 and 2. Whatever. This one will be 0. This one will be whatever. So the largest we can form here. That's true. How about here? The largest for here. So we only say we go this direction and this direction, right? So we don't consider the bottom direction. So we say the possible is the largest plus sign at the largest you will see at this position. When we count this, how do we count this? And we're only doing 2 directions, not 4 directions. Like, say here, this one. Unless we're talking about not a, it has to be a row, right? Oh, I think it's talking about 4 directions. You find the largest for 4 directions, and then you get that. Okay, so let's say we have 4 DPs. So we just straight through, right? This we keep counting, and then once it can count to 0, we reset. So we go this direction, right? And then once we're done, we go the reverse direction, and we go this direction, and then we go this direction, and we iterate through every single one. Feels like a now that I explained this way, it doesn't feel like too hard. So we're gonna have up. Up gonna be 0 times n for this in range n. Up, down, left, and right. Right? And then for I in range n, j in range m, right? And I go this way, and then if j, right? If j is if j is not j, if oh, are we gonna fill it up first? We can turn mines into a set. Why not? We can turn mines into a set. So we just say if Otherwise, it's going to be well, 0, and then otherwise it's going to be +1. Yeah, so let's do this. So I think just change minds set equals set, right? And xy, x plus y times 1j for xy in minds. So I turn that into a set, and then we say if I plus j times 1j is in minus set, not in minus set, j is equal to 0, right, the first one. Oh, not in this. If j is equal to 0, then look into the left, so it's left. Ij equals 1. Else, left. No. Ij equals left I, j minus 1 plus 1, right? If it's in, then we don't do it, it will remain 0. So we're going to do this for the left. And minus 1. Actually, it doesn't matter. I'm going to go just n. And this j is going to go from m. Oh, there's no m. Everything is n. So j, we can go n minus 1, minus 1, minus 1. Right? Again, same thing. If it's not in, and if j is equal to n minus 1, then equals 0. Otherwise, that's going to be plus 1. Right? So it's not left. This is going to be right. What's next? Copy and paste both. But here, j is going to go. So j in the range n. Here, j in the range m. For I in range m. It's no m. Both are n. Right. So for j in range and for I in range, right? So I 1 by 1. Again, that's the same thing. If it's not in, if j, let's come the top is, yeah, otherwise, okay, that's not left. That's going to be up, right? So up equals I minus 1. J, and then this is not j, this is I. I equals 0 the top row, otherwise it is. And this is going to be for I in range from bottom up, right? Bottom up. So it's going to be I. This is going to be down, right? So this is going to be down. This is going to be I plus 1. J plus 1, right? So after we've done that, we're going to go for I in range n, for j in range n, say res equals rank 1, no, rank is 0, right? So what do? We say if res equals max res, and the minimum of up ij, left ij, right ij, and down ij. And now return res. That's solution 2. Oh, I think this is it. Yeah, it is. It is actually not hard. I don't know, I got into the wrong mindset. No, come on. Yeah, you should pass. It's slow, but you should pass. Yeah, 3,000. It's about right. Look at these people. 250. Wow. All right, let's check it. So this one, using the hint, we create 4 DP table to record the number of ones encountered, encountered before a 0 in 4 directions. Then the highest rank plus sign that can be formed at any location is the mean value of the 4 directions. Runs in O n squared. Oh wow. I don't think this is a hard question. And this is a medium, but it's one of those medium that got me stuck. Royally stuck. Alright, let's take a look. 7. Oh, yeah, I feel like I shall be able to figure out this by myself. So run time is 3,000 something, right? And remember, I think it's 3,000. 3772. 3772. Yeah, no ranking. 3772. All right, let's take a look. I know the brute force cannot work. All right, let's see the DP approach. I feel like this is different from what I'm doing. We only do 2 rounds, right? Let's see. We know the longest possible arm length each direction. From a center, we can know the order. Wait, how do you know that by just go two directions? And for each coordinate, let's compute the count. The longest line of ones starting from and going in that direction is either 0, else is 1 plus the count going in the same direction. We have it like this. The corresponding count should be 0, 1, 2, 3, 0, 1, 2. That's the same. Band. dp. Hold on. What are we doing here? For R, we're talking about rows. Oh, we do it on the same one. Ah, I see. Still O(n) squared, but yeah, we can do on the same. Huh. Look at you, I created 4. Let's try that one more time. Alright, solution 3. From the official solution. Use only one DP table. Come on, man. You don't have to have DP, right? And these two can be combined because we can do this, right? And we're gonna say count is 0. Yeah, we can do count is 0. And for this, we say if this is not in mine, then count plus equal to 1. All right, and then this equal to, what is this equal to? Anyway, else count back to 0. What is equal to? Because we have only one DP. All right. Well, this is going to equal to, yeah, we have 1. So this is, let's say, to the left. To the left. Looking to the left. Looking to the left. So a count we can have in this position so if you want a minimum, so it should be a large value. So we're trying to look for the minimum, right? So if we have n, and this is going to be minimum, dpij, right, and count. That's just going to be keeping the minimum value. Else, count equal to 0. And we'll do the exact same thing. right? And then we reset count to 0. Do this. If it's not, count plus equal to 1, and this is going to equal to a minimum. This and count. And then we do these two together. Count equals 0. And that's the same. Oh, we forgot else. Shoot. Reset count. Right, then count is 0. If this and else. Count equals 0. That's the dpij. See, solution 3. Nope. Nope. Why? How does this return 1? I think it's this. It's not a mindset, then we cross 1, otherwise it becomes 0. So that is so we can do this. Count equals 0 if I plus j times 1j in mindset else count plus 1. Right. Try again. Now we pass. Alright, and then it's late, so I don't think I'm gonna try other solutions. So the last one. Probably similar time because I didn't really change anything. Oh, I think this one's even slower. What? How? How is this one slower? That doesn't matter. Doesn't matter. But just one grid. On square. I just put this together. It's fine. Posted in 2018. I have all the sorting and stuff. Yeah. I don't bother. I should have come up with this. Anyway. Alright, 2 hours today. I didn't do very well. I'll see you guys tomorrow. Adios.